Volcanoes spewed clouds of noxious gases, and Earth was enveloped in a suffocating atmosphere of carbon dioxide, nitrogen, and steam. With no oxygen to breathe and no ozone layer to block the lethal ultraviolet radiation, this was not a hospitable place for life, at least life as we know it. And in the midst of this hellish brew, the moon was born. Beginning when I was about 11 years old, I used to climb the stairs to the roof of this apartment building where my family lived here in New York City, a building prophetically named the Skyview Apartments. And with simple binoculars just like these, I gazed up above the streetlights, beyond the buildings, and into the night sky. And nothing will ever capture the excitement I felt when I first turned my binoculars on the moon. When I saw that the moon was packed with mountains and valleys and craters, I thought I discovered an entire new world. And then I began to wonder, where did the moon come from? And how did it get there? Well, little did I know that about the same time, the mystery of the moon's origin was also attracting the attention of a scientist named Bill Hartman.
I'm always looking at the moon and thinking about its phases, and when I was a little kid I had a telescope. I used to be out there drawing craters on the moon and was very excited that I could even see these craters in mountains and so on. So it's always had a special interest for me.
Hartman has been studying the moon for the last 40 years. And when he began his career in the late 1960s, he and many other planetary scientists hoped that NASA's Apollo missions would solve the mystery of how the moon formed.
One of the pitches to sell that program scientifically was that we were going to be able to go to the moon and find these old rocks from 4.5 billion years ago, and they were going to tell us everything about the origin of the moon.
The Apollo astronauts collected hundreds of rocks from the moon's surface.
Look at the size of that biggie. It is a biggie, isn't it? This one right here? That's it. You got it right there.
Scientists calculated their age using radioactive dating. To their astonishment, they discovered that the moon was millions of years younger than Earth. And those same rocks held another secret.
I think the biggest single surprise was that the materials on the moon had exactly the same chemistry as the Earth and different from any samples that we have anywhere else in the solar system. So that pretty well forced the idea that the moon has to form from the same basic material as the Earth.
But even more mysterious was that the moon rocks contain very little iron, just like the rocks on Earth's surface. In a flash of inspiration, Hartman and a colleague came up with a controversial new theory for the formation of the moon.
That's not bad. Yeah. We came up with this very simple idea that maybe as the Earth was forming, at our distance from the sun, somewhere nearby, made out of the same material, was a second largest body, which got pretty big before it finally plowed into the Earth.
They proposed that about 50 million years after Earth had formed, a huge planetesimal was still roaming the solar system. This massive rock, about the size of Mars, slammed into our planet. The energy of that impact was so great, it melted both the planetesimal and Earth's outer layers. The two fused together, forming a new, larger Earth. At the same time, this enormous collision ejected into orbit vast amounts of molten rock. This debris eventually coalesced to form the Moon. When Hartmann first went public with this idea in 1974, it was considered scientific heresy.
So here we come in saying the Moon formed out of this gigantic catastrophe that blew off part of the Earth's mantle. No one wanted to hear that. No one wanted to start thinking about that kind of model. All of us were taught as junior geology students that all processes in geology are slow, one sand grain at a time, erosion, and so on. And people would actually come to us and say, you know, we really shouldn't consider that model until we've exhausted all other models.
Ten years passed before anyone would take the idea seriously. And that was only after hundreds of computer simulations showed that the Moon could have formed from a giant impact. Today, Hartmann's big idea is almost universally accepted.
So it's been a long, slow process, and it's been really fun to see, you know, a little idea that you had a long time ago suddenly blossom forth as a leading theory.
It was 16 minutes past midnight, 50 million years after our planet was born, and the Moon had arrived. But the repercussions of this disaster were just beginning to be felt. The Moon started out about 200,000 miles closer to Earth than it is today, and appeared many times larger in the sky. Earth was spinning much faster, making each day just 6 hours long. And with the Moon so close, its gravitational pull on Earth was enormous. Earth's surface rose and fell up to 200 feet during the cycle of the Moon's phases. Over time, Earth's rotation slowed down as the Moon drifted away. A process that continues even today.
The idea of being able to measure the movement of the Moon away from the Earth has always been a challenge. And so when the astronauts went to the Moon, one of the things they did, they carried out this big device, which was a reflector, a retro-reflector, that would beam a laser beam back in the direction that it came.
On Earth, astronomers installed a laser so strong it could target the reflectors. In 1969, they made their first measurement of the time it took for the laser beam to reach the Moon, hit the reflector, and bounce back to Earth. A round trip of about 2.5 seconds.
Doing this year after year after year, we've actually been able to confirm that the Moon is moving slowly away. We not only get very exact information on the orbit of the Moon, but we can actually see the orbit change.
Now about 240,000 miles from Earth, the Moon is moving away at a rate of 1.5 inches every year. The collision that created the Moon was also a major stroke of luck for Earth. That impact was so immense that it forced Earth's axis to tilt in relation to the Sun, causing the familiar seasons. And without the stabilizing influence of the Moon, Earth would wobble dramatically about its axis. Today, the planet would experience wild climate swings,